Welcome back to Better AI Bots, where we take a mountain of dense information, slice it up, and distill it down to the pure knowledge you actually need.
Today, we are jumping right into what our sources describe as, well, the most dramatic power shift in the semiconductor industry in decades.
The AI chip wars?
Exactly. And this isn't some abstract battle fought in server rooms. I mean, this is the fundamental infrastructure powering the entire AI revolution.
Right. If you've been following the AI boom at all, you know NVIDIA has held a near monopoly on the hardware that trains these huge language models.
But the core mission of this deep dive is to analyze the material showing exactly how that status is now cracking under enormous pressure.
And we know this topic, semiconductors, architecture, accelerators, it can sound incredibly dense. It's full of jargon and acronyms.
Sure.
Our goal here is to keep it simple, accessible, and really focus on the surprising so what for you. Whether you're a developer, a startup founder, or just someone trying to understand the economic future, we're here as your guides.
Right.
And we certainly don't claim to know everything.
Not at all. We just know how to read the research and hopefully translate it.
So the central conflict here is powerful. NVIDIA's dominance is being eroded by everyone, it seems.
By longtime competitors like AMD and, crucially, by its own biggest customers.
And this matters because it's not just about slightly faster chips, is it?
No, it's about who controls the future of AI, who can afford to build it, and whether innovation moves beyond the exclusive multi-billion-dollar playground of just a few tech giants.
Okay, let's unpack this. Let's see how NVIDIA built their empire and how that very success created the massive demand.
And the cost crisis.
And the cost crisis that makes everyone desperate for an alternative today.
Absolutely. Let's get into it.
The rise of NVIDIA it's one of the most compelling origin stories in modern tech. It started in the early 2010s, but it wasn't really designed to happen, was it?
Not at all. It was a beautiful, serendipitous moment of discovery.
So, explain the accidental genius here. How did a company known for rendering dragons and explosions in video games suddenly become the king of AI?
It was driven by early deep learning researchers. They were struggling, really struggling, to efficiently train their massive neural networks using traditional CPUs.
Okay.
Then they realized that graphics processing units, or GPUs, which were designed to do thousands of simple math problems at the same time for graphics.
Right, for making things look pretty on screen.
Exactly. They realized that structure was absolutely perfect for the highly parallel computations needed to train these really complex networks.
So the key insight was that training AI is just a massive parallel processing problem, and GPUs were already built for that. But it wasn't just the silicon, was it?
No. And this is the true brilliance of NVIDIA's strategy. This is why the lock-in is so intense.
Okay.
They secured their advantage not just in hardware, but in software, specifically their proprietary platform called CUA.
So they didn't just sell you a shovel.
No. They built the entire toolbox, the operating system for the shovel, and then all the construction crews learned how to use only that toolbox.
And by the time the rest of the world woke up to the AI regression, the source material suggests NVIDIA had a decade-long head start that nobody else could touch.
A proprietary head start, too. All the key frameworks, PyTorch, TensorFlow, they were all optimized for CUDA.
That ecosystem, that software moat, that's far more valuable than the chips themselves.
Precisely. And the financial results are just staggering.
I mean, numbers are hard to even comprehend.
Their H100 and A100 chips became essential, like liquid gold. This drove their data center revenue from around $15 billion in 2022 to projections of over $100 billion by 2025.
And we even saw their market cap briefly surpass $3 trillion.
$3 trillion, it's astronomical.
But history tells us that monopolies, even wildly successful ones, often create the conditions for their own vulnerability. And the sources are unanimous on what that weakness is. The AI cost crisis.
It's the uncomfortable truth driving these chip wars. Training and running these truly large models requires thousands of GPUs. And NVIDIA's pricing, well, it reflected their market dominance.
And the sheer lack of alternatives. So to make this real for our listener, what is the cost of admission to the AI big leagues?
It's brutal. The specific detail from the sources is that training OpenAI's GPT-4 reportedly cost upwards of $100 million.
$100 million.
And a massive percentage of that was just for the compute infrastructure. For a startup, or even a mid-sized company, renting access to these NVIDIA chips can cost thousands of dollars per day.
So if you're trying to build the next killer application, that kind of capital means innovation is largely limited to well, to the giants.
Exactly. It raises the barrier to entry so high that it naturally concentrates power.
And beyond the cost, there was another lesson, right? The supply shortage.
The industry learned a painful lesson about dependency during the chip shortage of 2021 to 2023. Major projects just stalled because companies couldn't get chips at any price.
So that realization that the entire industry had a single point of failure, that's what really changed the market's perspective.
It changed everything. Everyone realized they needed options.
Okay, so if NVIDIA is the entrenched emperor, AMD is the obvious challenger that has suddenly gotten very, very serious.
Yeah.
They've always been seen as the scrappy alternative, but the sources paint the MI300 series as a genuine high-performance threat.
They're no longer just the alternative. They are a direct competitor. Their MI300 series, specifically the MI300X accelerator, offers comparable performance for a lot of these demanding AI workloads.
And they're leveraging a couple of key advantages to close that gap. First, let's talk technology. The chiplet design. Why is that such a game changer?
Chiplet technology is key. Instead of trying to build one massive, perfect chip, which is really hard to manufacture.
Well, the bigger it is, the more likely a flaw.
Exactly. AMD builds several smaller, specialized chiplets, like compute, memory, and I/O, and it basically stitches them together in a single package.
And what does that do for them?
It significantly increases their manufacturing yield and lets them pack dramatically more computing power and, importantly, more high-bandwidth memory into a single accelerator. And that memory capacity is vital for the biggest AI models.
Okay, that's the hardware side. But we just established that the real lock-in is software, the CUDA mode. How is AMD tackling that?
This is their biggest hurdle, no question. They offer something called ROCm, which stands for Radeon Open Compute.
It's their open-source alternative to CUDA.
Right. And strategically, this is brilliant. Developers often prefer open source. But practically, it's an immense uphill battle.
Why is it so hard for developers to switch? If the hardware is competitive, why not just, change the software?
Because every academic paper, every established code library, almost every developer's muscle memory is built on CUDA. Converting that code to ROCm isn't always a simple recompile. Developers have long reported that while ROCm is improving fast, it still lacks the maturity and documentation that CUDA has built up over a decade.
So it needs a big push from the community.
A massive community effort and commitment from major players to smooth out those kinks.
And that's where we're seeing the market shift. Major players like Microsoft Azure and Oracle Cloud are investing heavily in these MI300 instances.
That's the signal you need to watch. Meta is also publicly integrating AMD chips.
So the takeaway here is that AMD's strategy isn't necessarily to be better on every single metric.
No, it's to be the reliable, widely adopted alternative. When a market is desperate for supply, being good enough, well-supported, and available is strategically invaluable.
Okay, so if AMD is attacking from the outside, the next major threat comes from within, the hyperscaler revolution.
And this is where it gets really interesting.
Because NVIDIA's biggest customers are designing their own chips, which will eventually displace their purchases.
This represents, an existential threat to NVIDIA's core business model. If you lose your highest volume buyers, you lose the economy of scale that fuels your innovation.
It's a huge deal. The hyperscalers, Google, Amazon, Microsoft, are moving from being dependent buyers to independent builders.
And look at Google. They pioneered this nearly a decade ago with their tensor processing units, or TPUs.
Right. Their latest TPU V5e and V5p chips are now core offerings through Google Cloud. What's the main motivation for that huge effort?
Control and specialization. Google is perhaps the world's largest consumer of AI compute.
Search, YouTube recommendations, all of it.
All of it. Building custom chips means they control their internal costs dramatically. But more importantly, they optimize performance for their specific workloads. They aren't adapting their models to general-purpose chips. They're designing the hardware for their software.
And Amazon Web Services is just as aggressive. They built two distinct custom chips, Trainium for training and Inferentia for inference.
Which is for running the models efficiently.
Exactly. And I found it fascinating that Amazon claims their Trainium 2 offers up to 30 to 40% better price performance than comparable GPUs for certain workloads.
And we've seen major validation of this ecosystem. Anthropic, the company behind the Claude models, announced they're exploring AWS Trainium chips for training future models.
That is a loud signal.
It's huge. When a company at the absolute frontier of AI considers moving massive workloads away from the NVIDIA stack, it validates the entire alternative chip ecosystem.
And Microsoft is playing the same game, developing its own accelerator called Maya.
Yep, designed specifically to run large language models within its massive Azure data centers.
So if Microsoft can power its huge Azure AI business and its partnership with OpenAI using its own chips.
It could save them billions a year. This isn't just about diversification anymore. This is about eliminating a massive line item from their budget while guaranteeing supply and maximizing performance.
Now let's talk about the startup insurgency. While the giants are battling over general-purpose silicon, a wave of startups is questioning the fundamental GPU architecture itself.
Right, they're looking for specialized advantages where NVIDIA's general architecture might fall short. They're trying to create niche ecosystems where they can leapfrog the CEDA challenge by offering something radically different.
Take Cerebra Systems, they went to the absolute extreme.
They really did.
They build what they call the Wafer Scale Engine 3. It packs 4 trillion transistors onto a single silicon wafer. Why would you ever do that?
Because latency is the enemy of massive parallel training.
Okay, explain that.
In a traditional setup, you link thousands of small chips together, and they constantly have to send data back and forth. That creates bottlenecks.
Right.
By putting all the compute power on one giant piece of silicon, Cerebras eliminates those communication bottlenecks for certain tasks, like complex scientific modeling or drug discovery.
Then you have Grok attacking a completely different problem, pure inference speed.
Yeah, they created something called language processing units, or LPUs. They're designed specifically for running trained models with extremely low latency.
We've seen demos showing dramatically faster token generation speeds.
And that speed is absolutely critical for the next generation of AI apps. If you're talking to a conversational AI, every millisecond of delay makes the interaction feel laggy or unnatural. Grok makes real-time, instantaneous AI communication possible.
But the challenge for all these startups is immense, right?
It's huge.
Yeah.
They still have to overcome that CUD mountain and convince developers that the performance gain is worth the friction of adopting a whole new niche programming stack.
We can't discuss the chip wars without connecting this to the biggest picture of all: global geopolitics.
For sure.
The sources highlight that U.S. export restrictions on advanced chips to China, which were intended to slow their progress, may have had a massive unintended consequence.
The intention was to maintain a competitive lead, but the effect was to basically force Chinese tech giants like Huawei and Alibaba to accelerate their domestic chip development dramatically.
So they're just building their own.
They're investing billions to close the performance gap using their own foundries and designers.
So instead of slowing them down, we're essentially creating 2 parallel and increasingly separate AI ecosystems.
That appears to be the long-term implication. We're seeing a bifurcation of the global chip market. Chinese companies are developing on Chinese-designed chips and software, while Western companies use NVIDIA, AMD, or custom silicon.
And that separation could mean we eventually see 2 totally distinct paths for AI capability.
It could limit interoperability down the line, yeah. And this is why governments globally, from the XGPS Act in the US to similar programs in the EU, now view AI chip production as a matter of strategic national capability.
It's not just business anymore.
It's national security.
So what does this multi-front war mean for you? For the developer, the entrepreneur, the learner? The sources suggest this dramatic competition is overwhelmingly good news.
Absolutely. The biggest takeaway is that the barriers to entry are finally lowering. As costs moderate and alternatives become available, AI development becomes more accessible.
To mid-sized companies, academic institutions.
Diverse teams everywhere, not just the top 10 tech companies. That accelerates innovation.
We're also going to see specialized optimization really take off, right? Instead of everyone building models around the constraints of a GPU.
Models will be designed to leverage specific hardware. Think models optimized for Grok for low latency or Amazon Trainium for cost-efficient training. This leads to far more efficient systems.
And critically, we gain resilience.
Yes. Multiple chip sources, from AMD to Google to the startups, mean reduced supply chain risk. The industry is less vulnerable to a single manufacturer's production issues. The whole system becomes more robust.
And the cloud providers are already passing on savings.
They are. Using their custom silicon, they're already offering cheaper AI compute alternatives compared to the high cost of standard GPU instances. It's pushing down prices across the board.
So the future isn't defined by one winner taking all. It's a multi-tiered, multipolar ecosystem.
That's the most likely scenario, yeah. NVIDIA probably maintains the high end for the absolute bleeding edge of research.
AMD captures the practical middle ground with better availability and pricing.
The hyperscalers dominate their internal workloads for cost control. and startups find those critical niches like ultra-low latency.
So the bottom line is that the real winner is the entire ecosystem.
It's the developers and entrepreneurs who now have more options, lower cost, and a much greater opportunity to participate in the AI revolution.
That is a fantastic summary. The challenge to NVIDIA's empire is leading directly to the democratization of AI compute.
And that competition is exactly what the industry needs right now.
It really is.
And here's a provocative thought for you to consider as you digest all this.
Okay.
Given that the U.S. restrictions have accelerated domestic Chinese chip development, will these two parallel AI ecosystems, the Chinese hardware stack and the Western stack, will they eventually diverge so much that they lead to entirely different core AI capabilities, applications, and maybe even philosophical approaches globally?
Wow. Something serious to mull over. Thank you for diving in with us today.
My pleasure.
Until next time and our next Better AI Bots Deep Dive, check out the website and explore the guides and quizzes and up your AI knowledge.